Introduction exercise 9K on box plots, page 624 of your textbook. Now for our do now question, we're identifying the 5-number summary of the data and then interpreting, keyword being interpreting, the IQR. Let's start by finding our different values. So the weights in kilograms of 14 parcels are lodged at a post office an hour before closing, and they're listed as below. I've written the values from smallest to largest, thank you very much. Which one do we want to start with? What part of the 5-number summary do we want to start off with? Yeah. Easy. Minimum, maximum seem easiest to me, so I'm going to write down 0.4 being my minimum value and my maximum being 3.5. Awesome. So we've already labeled 2 of our 5. Let's find the next easiest one. Let's do the median. Now, if it's the median, I've got 14 bits of data. I can go count 1, 2, 3, 4, 5, 6, 7. This would be my 7th value. If I go the other way around, 1, 2, 3, 4, 5, 6, 7. Yep, 1, 2, 3, 4, 5, 6, 7. This would be my other 7th value from the right-hand side. So how do I find my median? Average between the two. What's the average or the middle point between 1.8 and 2? 1.9. How'd you do that, Samia? Just perfect. Add them together and divide. In this case, you guys can use your big brains and just look at it and know that the middle is 1.9. So you can write 1.9 there. Now we should know, based off our 5-number summary, that Q1 must be between 0.4 and 1.9, and Q3 must be between 1.9 and 3.5. What's another way of saying median? It's not average. It's between Q1 and Q3. You could say the middle number, but you could also say Q2. Q2 is another name for median. You might see it, you might not, but if you do see it, just think median. So let's focus on this one here. So we said 1.9 is there. Let's cut it off there. We've got 1, 2, 3, 4, 5, 6, 7 values left. Let's find our Q1. So that's going to be our 4th value in. So that's going to be 1.2. And of course, same thing with the right-hand side. We're going to go 1, 2, 3, 4. It's going to be this value, 2.6. Are we done? Happy? Happy to move on? IQR. IQR, good. So IQR, what's the formula for that again?
Q3 minus Q.
Very good. We subtract our Q3, so 2.6, by 1.2, which is our Q1, which gives us an answer of 1.4. Why can I not just leave my answer there? Have to interpret. What does the IQR mean? Well, it means the middle 50%. So you could say, and if I get my text boxed out, here we go. So we can say the IQR means that 50% of the data is within a 1.4 range. So that just means that our data that we have is going to be within a 1.4 range. And we can see what that looks like in a box plot. Alright, let's move on to today's content. So with a 5-number summary, it gives us a better picture, but it's not very visual. Right? You can't look at these 5 numbers and think, great, that means a lot to me. Unfortunately, it's not very visual, so we can represent this data. We can depict this information using a box plot. So for example, as you can see here, very creative names by the textbook. They've got Box High School and Plot Secondary College. You can see as soon as we put those 5-number summaries into our box plot, it's a lot easier to compare. What differences can you find, or what similarities can you find between the two?
They both have a box.
They both have a box, sure, but let's look a little bit further. Let's look about what the numbers would represent. Which ones, let's say that these are the scores on a math test. Which one did you say is the better, quote-unquote, better school? There's no wrong answers here. What's the better school for marks? Yeah, Zinzi.
Plot secondary.
Plot secondary, why?
Because the data is skewed higher.
Okay, so you're saying because the Q1, Q2, Q3 is to the right. I agree, but I'm going to give you a counter argument. Isn't the maximum of Box High School going to be higher, so therefore they've got better results?
Well, overall they have more higher results than
I agree, absolutely. Remember, the IQR represents the middle 50% of data. If you focus on that middle 50% of data, that's between Q1 and Q3. Now for us, the box's width represents that 50%. Now to me, I would interpret it very similarly. I'd say the overall, or the middle 50% of data for plot secondary is higher or more towards the positive side than box highs. Any questions? Okay, let's move on. Can I get you guys to write down or copy down this diagram for me? You're going to need the different words as well. Box plot, I've included the alternate name. Sometimes it's called box and whisker plot. But this is what it is meant to look like. And if you're missing any of the information here, whether you're drawing it for an assessment or for in your workbook answering questions, you're missing something. You must include all of these, barring the 25% values. You must include all of these, unless otherwise you would lose a mark. Alright, so let's break it down. Well, we've got a scale. Now, something that we don't talk about in mainstream as much, but something I do want to encourage you to think about, is the scale. Now, in VC mathematics, assuming that the majority of the class wants to do VC mathematics, something we look at is called reasonable scale. Right? Sometimes when we do graphing, when we do box plots, anything of the sort, we do something called reasonable scale, and there's mark allocated towards reasonable scale. What that means is that your scaling needs to be consistent and within a reasonable frame. So for example, if I'm looking at the results of students on a test percentage-wise, I'm not going to have maybe 1 to 5 percentages, because that's going to be very small. Let's say the general amount of data is between 40 and 80. Or we need to make sure that the scaling is the same, consistent, right? If we're going up, if for each line we're going up by 5%, it needs to stay the same for the rest of it as well. So consistent scaling. We only have one axis as well. It's important to know we only have one axis. It does not matter how high up you draw a box plot, as long as it's not something ridiculous, of course. Each one of these sections represents 25% of data. So between here and here is 25%, between there and there is 25%, here's 25, and here's another 25 as well. We do not do outliers in this circumstance in terms of proving outliers, but we don't have to worry about that. So for us, it's just 25% and 4 chunks of it. The box, as you can imagine, is just the middle part. Why is this line not in the middle of the box? If it's the median, shouldn't it be exactly between Q1 and Q3?
No.
Not always. In fact, most of the time it's not.
Unless it's average.
We know in this case, our data is asymmetrical. What does that mean again? Asymmetrical. And don't use the word symmetrical, please. Asymmetrical. We know what symmetrical means. It means reflected across the middle part of the data. So asymmetrical means...
Like, even on both sides.
That's what symmetrical means. Good. So in this case, asymmetrical means it's not even on both sides. Is there an issue? Okay. We know that the median is going to be closer to the Q1, or the first quartile, than the third quartile. But it still represents 25% of the data. Think of it as 25% of each data point, the data points. And we have minimum, Q1, Q2, or the median, Q3, and maximum. Would you like me to leave this on the screen for a little longer? Yeah? Okay. I will scroll down, but I'll leave that up on the screen. Let's use this example. This box plot summarizes the number of air conditioning units sold at an electrical store each day in summer. Again, as you can see, the number of sales is one single axis. We don't have two axes. And we have the minimum, maximum, and our 5-number summary. I'm going to label that here first. So we have our min, we have our Q1, Q2, Q3, and finally our max. The first question says determine the 5-number summary. I'm just going to write the values here so you can see it still. Our minimum is going to be 0. Our Q1 is going to be equal to 10. Q2 is 15. Q3 is 25. And the maximum equals to 30. That's my 5-number summary. It says 50% of days had sales below what number? Now, this is when we need to think back to the 25% chunking. Where is the middle 50% of data? Yep. 15, good, because that's Q2, isn't it? So if I said 50% of data had days, sorry, 50% of days had sales below what number, the answer would be 15 days. If I said there were 80 days of sales, on how many days would there be fewer than 10 sales? Now, this one is a little bit trickier. Fewer than 10 sales. What percentage of sales, or days, were fewer than 10 sales? What percentage? Well, I know 10 is going to be here. So fewer than, is that left or right? Left. What percentage is that?
33%.
Remember, referring back to my whisker up here. What percentage is it from the box to the very minimum? 25%. So I know that 25% of sales are going to be fewer, of days, sorry, are going to have less than 10 sales. I'm going to try that again. 25% of days are going to have less than 10 sales. Is that my answer though? Is that what I'm looking for? No. What I'm looking for is if there were 80 days of sale, and this is where our understanding of experimental probability comes in. 25% of them are going to have fewer than 10 sales. So out of 80, oops, out of 80, that's going to give me an answer of 20 days. Any questions about that? No? Okay, awesome. I'm going to